everyone, welcome back to the channel where we break maths problems down one step at a time. It's time to take the fear out of algebra. Today we're simplifying a really big expression with fractions and a division sign in the middle. But don't worry, we're going to take it slow, and by the end you'll see just how to solve this sort of problem in the future. The expression we're working with can be seen on the screen, and our goal is to simplify it fully. Before we dive in, we've got to talk about one key skill, which is factorising. Factorising is basically reverse expanding. You're looking to break an expression down into brackets that multiply together. Let's take, for example, the expression x squared plus 5x plus 6. We want to look for two numbers which multiply to 6 and add to 5, so that we can factorise this expression into two brackets. A pair of numbers that does this is 2 and 3. So in one bracket we'll have x plus 2, and in the other we'll multiply it by x plus 3. Now expanding this out using the method, we get x squared, because x times x is x squared, 3x, because 3 lots of x is 3x, 2x, because 2 lots of x is 2x, and 6, because 2 times 3 is 6. When we combine this all together, we get x squared plus 5x plus 6, which means we've managed to factorise the brackets correctly. The key takeaway is to find something that multiplies to the last term and adds up to the middle term. And we need to factor a lot of fractions like this before we can do any more algebra. Going back to our question, we can see lots of polynomials that need solving. Let's take this one piece at a time. First up, let's look at the first fraction. 2x minus 12 divided by x minus 4. We need to ask ourselves, can we factorise the numerator? Can we factorise the denominator, which are the top and the bottom of the fraction? To start off with, can we factorise the numerator? Yes, we can. If we take out a factor of 2, we get 2 lots of x minus 6, because 2 times x gives us the 2x, and 2 times minus 6 gives us the minus 12. We now need to ask ourselves, can we factorise the bottom? No, there's not a common factor between the two, so the bottom remains as x minus 4. Now the second fraction is a lot more involved. Let's take our first fraction and put it over to one side for a moment. We'll come back to it. The second fraction is 2x squared minus 6x minus 36, all divided by x squared minus 9x plus 20. This is a bit more hard because we've got a 2 in front of the x squared. But anyway, let's crack on and factorise the top and the bottom if we can. Let's start with the top and take out a common factor of 2, because all the coefficients are even. So we get 2 lots of x squared minus 3x minus 918. We can check that this is correct by expanding it out mentally to get 2 lots of x squared minus 6x minus 36. Let's now factorise the quadratic inside the bracket. So we've got 2 lots of x something times by another x term. We want two numbers that multiply to minus 18 and add to minus 3. The numbers in this question would therefore be minus 6 and plus 3, because minus 6 times 3 is minus 18 and minus 6 plus 3 is minus 3. So we can go ahead and put those into the brackets. Please note, it doesn't matter which number you put where. So this becomes our numerator. let's mark it and we'll come back to it once we've factorised the denominator. Our denominator is x squared minus 9x plus 20. Once again, we're looking for two numbers that will multiply to 20 and add to minus 9. The two such numbers are minus 4 and minus 5, because minus 4 times minus 5 is 20, and minus 4 plus minus 5 is minus 9. So let's go ahead and put those into our brackets. So here we have it. We have both the top and the bottom of the fraction, which we can now combine into 1. So on the top, we get 2x, lots of x minus 6, x plus 3. And on the bottom, we divide it by x minus 4 and x minus 5. This takes care of our second fraction. So now we've factorised both the first fraction and the second. We can combine the two to get our answer, to get towards our answer. So we get 2 lots of x minus 6 divided by x minus 4, all divided by the second fraction, which is 2 lots of x minus 6 times by x plus 3, and all divided by x minus 4 and x minus 5. Now, to deal with the division sign. When dividing two fractions, we keep the first one the same, we flip the second one upside down, and we change the sign in the middle. So let's do just that. We get 2 lots of x minus 6 divided by x minus 4, because we keep the first one the same. We change the sign to a multiply, and we flip the second one. So we get x minus 4 times by x minus 5 on the top, and 2 lots of x minus 6 times by x plus 3 on the bottom. This is what we now need to simplify to get our final answer. So here comes the fun bit, seeing what cancels out on the top and the bottom. When you multiply fractions, the numerator on both, so the top bit on both, multiply with each other, and the bottom bits multiply with each other. However, if there's a number or a term that's on both the top and the bottom of the fraction, we can cancel it out, which I'll do now in red. For example, there's a 2 on the top here and a 2 on the bottom here. So we're essentially dividing both fractions by 2. We're cancelling out the terms. Similarly, there's an x minus 6 up here and an x minus 6 up there. This leaves the top of this fraction as just 1 because everything else has been divided through. Now comparing the denominator of the first one, we have an x minus 4 at the bottom here and an x minus 4 up top here. This makes the bottom of the fraction a 1 as well. We can rewrite this clearly as 1 divided by 1, lots of x minus 5 divided by x plus 3. This makes it a little bit more clear as to what's left. Now anything times 1 is itself, and so lo and behold we have our final answer of x minus 5 divided by x plus 3. This is as simplified as it gets because nothing can be further cancelled out here. So we can put a nice little box around it to get our final answer. Well, there we go. What started as a chunky looking algebra problem turned into a clean and simple fraction, all thanks to skills such as factorising and cancelling common terms. If this helped you feel a little bit more confident about algebra, give it a thumbs up, subscribe for more walkthroughs, and drop a comment below if there's a topic you'd like for me to cover. You've got this. See you in the next one.